Okay. In question 1, it says expand 3 plus x into 1 minus 2x power half in ascending powers of x up, including the term in x square. So we'll leave 3 plus x as it is. Now expanding 1 minus 2x, the formula is 1 plus nc1. So nc1 is n. So this will become 1 upon 2 into b power 1. So minus 2x to the power 1 plus nc2. Now we can calculate the value of nc2 over here. nc2 is n into n minus 1 upon 2 factorial. So this is half into half minus 1 divided by 2. Half into half minus 1 is minus half. So this will become minus 1 upon 4 divided by 2. So this will become minus 1 upon 8. So this will become minus 1 upon 8 nc2 into b squared. So minus 2x whole squared. So this is the expansion over here. Now we'll get 3 plus x into 1. 2 and 2 will cancel. So 1 minus x plus, and this will become plus 4x squared, and plus minus is minus. So this will become minus 4x squared upon 8. Now, as we have to find the term in x squared, so first we'll multiply 3 by all of these terms. So we'll get 3 minus 3x minus, we can just simply write it as 1 upon 2. So that will become 3 upon 2x squared plus x into 1 is x minus x squared. And as we don't need the term in x cube, so we don't have to multiply x with x squared upon 2. Now, simplifying, we'll get 3 minus 3x plus x is minus 2x. And then 3 upon 2 minus x squared, that will become minus 5 upon 2 x squared. In question 2, it says solve the equation ln of x minus 5 is equals to 7 minus ln of x. So in the first step, what you will do is you will write it as ln of x minus 5 plus ln of x is equals to 7. Now, as this is a plus sign over here, we can write it as ln of x minus 5 multiplied by x is equals to 7. Now, as we know that the base is an exponential base over here, expanding this, this will become x square minus 5x. And this will be written as is equals to e to the power of 7. E to the power 7, when we substitute this in the calculator, so that will become e to the power 7. That is 1096. So x square minus 5x is equals to 1096.6. Bringing it on the right hand side, we'll get x squared minus 5x minus 1096.6 equals to 0. To solve this equation, we can simply substitute this in the calculator if we have it, or we can just use the quadratic formula, which is x is equals to minus b. So that will become minus minus 5 plus minus b squared, that is 25 minus 4ac upon 2a. So upon 2a, that will become 2. So 25 plus 4 times 1096.6. Taking the square root of this is 66.4. So 5 plus minus 66.4 upon 2. And then one of the answers will become 5 plus 66 upon 4. So 5 plus 66.4 divided by 2, that is 35.7. And we have to give your answer correct to 2 decimal place. So we should not have rounded it over here. So this will become 25 plus 4 times 1096.6. Square root answer, that is 66.418 or 42. So this will become 5 plus 66.42 divided by 2. And the final answer will become 35.71. And we cannot take the negative value, as if you put a negative value over here, this is not possible. ln of a negative value is not possible. So we'll just take the positive value, and the final answer will be 35.71. In question 3, it says that the variables x and y satisfy the equation a power y equals to bx. The graph of y against ln x is given, and the points are also given as shown in the diagram. We have to find the values of a and b and we have to give each value correct to the nearest integer. Now, the first thing we'll have to do is represent this equation in the form of a straight line. So the equation is a power y is equals to bx. In the first step, we'll introduce ln on both the sides. So we'll get y ln of a is equals to ln of bx. Applying the rules of logarithms, we'll get ln of b plus ln of x. Now on the x-axis, we have ln of x. On the y-axis, we have y. So we'll divide ln a on both the sides. We'll get ln b upon ln a plus 1 upon ln a. We'll divide with ln x as well. So as this is on the x-axis, this coefficient 1 upon ln a will become the gradient. So 1 upon ln a will be is equals to the gradient, and ln b upon ln a will be equals to the y-intercept. Now we'll find the gradient using the points given over here. So the gradient will be y2 minus y1. So we'll get 1.5 minus 1 divided by 1.31 minus 0.336. Substituting this in the calculator, we'll get 0.5 divided by 1.31 minus 0.336. That is equals to 0.51334. So 1 upon ln A is equals to 0.51334. Now to find ln A, we'll write it as ln of A is equals to 1 upon 0.51334. So A will be is equals to e to the power of 1 upon 0.51334. Substituting this in the calculator, we do first 1 divided by this value and then e to the power of this answer, we'll get 7.01. And as we have to give our answer to the nearest integer, so the value of A will be taken as 7. Now, we have A, we have to find the value of B. So in the first step, we'll find the value of C using y equals to mx plus C. So we have the gradient, which is 0.51334, and we can take any point over here. So let's take 1.31 and 1.5. So 1.5 is equals to 0.51334 times 1.31 plus C. We'll subtract this answer. So the value of C will be 1.5 minus 0.51334 times 1.31. So the value of C is 0.82752. So we'll get ln of B is equals to C times ln of A. So ln of B will become, so C 0.82752. So 0.82752 times ln of 7. So this will become times by ln of 7. That is 1.61. So ln of B is equals to 1.61. So B will be equals to e to the power of 1.61. So e to the power of this answer gives us 5.00. So the value of B will be equals to 5. In question 4, the complex number u is given by u equals to -1 minus iota root 3. In part A, we have to express u in the form r cos theta plus iota sine theta, and we have to give the exact values of r and theta. Now, if a complex number is given as u is equals to -1 minus iota root 3, so in the first step, r is equals to square root of x squared plus y squared. So r will be is equals to square root of -1 squared plus negative root, so negative root 3 whole squared. Now, this will be is equals to 1 plus 3. So the value of r will be square root of 4, which is equals to 2. And now to find the value of theta, this theta is given as, so we write tan theta is equals to y over x. But one thing we'll have to be careful about is that looking at the coordinates, we know that this is present in the fourth quadrant, as this is also negative, the x value, and the imaginary value, which is negative root 3, that is also negative. So as it is in this quadrant, our complex, this argument or this angle theta will be a negative value. So first we'll find this angle over here, and we can apply, so this is root 3 and this is 1. So we'll do tan inverse of So this theta will be tan theta is equals to root 3 upon 1. So theta will be tan inverse of root 3. So tan inverse of root 3 in terms of degree, and we have to make sure our calculator is in radian mode. So we'll do shift tan inverse of root 3 and we'll get theta is equals to pi by 3. Now, as this is pi by 3, this angle, as we measure, as the angle of theta has to be between pi and minus pi, so we cannot take this angle. This angle will be pi minus pi upon 3. So the actual value of theta will be pi minus pi by 3, which is equals to 2 pi by 3. So we have the value of r and theta. We can write it as 2 bracket cos of 2 pi by 3 and plus iota sine of 2 pi by 3. And just one more thing, that if we have measured it clockwise, so this has to be given as a negative value. So we'll have to make sure that we add a negative value over here as well. Now in part B, it says the complex number V is given. We have to express the complex number V upon U in the form R e power iota theta. Now whenever two complex numbers are dividing, like in this case, R V upon U, so the value of R will be is equals to the magnitude of V divided by magnitude of U. Now we already know that the magnitude of V is 5 and the magnitude of U was 2. So R will be is equals to 2.5. And we get theta by subtracting the argument of V from the argument of U. So the value of theta will be is equals to, this value is 1 upon 6 pi minus the argument of U was minus 2 pi by 3. Simplifying this, we'll get 1 upon 6 pi plus 2 pi by 3. Taking the LCM, so this will multiply by, so this will multiply by 2, this will multiply by 2, we'll get 4 pi plus pi, which is 5 pi by 6. So the final answer will become 2.5 can be written as 5 upon 2 e to the power iota 5 pi by 6. In question 5, the equation of a curve is given as y equals to e power sine x upon cos square. We have to find dy dx and then find the x coordinates of the stationary points of the curve. So in the first step, we'll find the dy dx, and as the terms are dividing, we'll apply the quotient rule, which is vu dash minus uv dash upon v squared. Now u, which is in the numerator, will be taken as e power sine x. So u dash will be is equals to the derivative of sine x is cos, and e power sine x, we can write it in the short form. V will be taken as cos square of x. So the derivative of V will be, this 2 will multiply over here, 2 cos, and the derivative of cos is minus sine. So we'll get minus 2 cos sine. Substituting this in the formula, we'll get Vu dash. So that will become cos square into cos, which is cos cube, e power sine x minus, and there's already a minus sign with V dash. So we'll make it a plus over here, and uv dash. So that will become 2 cos sine e power sine x divided by v square. So v square will become cos square whole squared. And as we have to find the x coordinates of the stationary point, we can just write 0 over here. Obviously, in your exam, you'll have to first show the dy dx, the whole term, and then in the next step, you'll have to write it equals to 0. Now, cross multiplying, this will become 0. So we'll get cos cube e square plus 2 sine cos e power sine. If you bring it on the left hand side, we can write it as cos cube e power sine x is equals to minus 2 sine cos e power sine x. This will cancel out. Cos cube and cos will cancel. So we'll have cos square remaining over here. And now we have cos square is equals to minus 2 sine x. We know the identity that sine square plus cos square is equals to 1. So cos square would be equals to 1 minus sine square. So we'll write it as 1 minus sine square equals to minus 2 sine. Making sine square positive, we'll take it on the left hand side. So this will become sine square minus 2 sine minus 1 equals to 0. Now we'll have to solve this quadratic equation. So applying the quadratic formula, we'll get minus b. So that will become plus 2 plus minus b squared minus 4ac. So that will become 4 minus 4 into 1 into minus 1 divided by 2a. So 2 into 1. So we'll get 2 plus minus square root of 4 plus 4, that will become 8 divided by 2. Now 2 plus square root of 8 divided by 2. One of the values of sine theta will be equals to, or sine x will be equals to 2.414. But as it cannot be more than 1 or less than minus 1, so we'll reject this value. And the other value of sine x will be 2 minus root 8 divided by 2, that is equals to 0.414. 4142. And then x will be is equals to, now the first step we always do when we have this trigonometric term is we'll find the basic angle. So the basic angle will be shift sine inverse of 0.4142 and we'll get 0.427. Now as it is a negative term, now we will make this in the negative quadrants. So we have A, C, T, S. The negative quadrants of sine are the third and the fourth quadrant. So we will make 0.427 over here and in the fourth quadrant. And our values of x have to be between 0 and 2 pi. So basically between 0 and 360. So now x will be, one of the values of x will be, we always measure it anti-clockwise. So that will become pi plus 0.427. And the other will be, so this will go up till here. So that will become 2 pi minus 0.427. So pi plus 0.427, that is equals to 3.569. So this is 3.569. And the other value will be 2 pi minus 0.427. That is 5.857. Now, as we have to give our answer to three significant figures, we can give our final answer as 3.57 and the other answer is 5.86. In question 6, we have to sketch a suitable pair of graphs and show that the equation cos half x equals to ex minus 3 has exactly one root between x equals to x between 0 and pi. So we'll have to first make the graph of y equals to cosec half x. Then we'll sketch the graph of y equals to e power x minus 3. And we'll have to show that they intersect at only one point. So now let's first make the x and the y axis. This is the y axis. This is the x axis. And we have to be between 0 and pi. So let's say this is pi upon 2 and this value is pi. Now to sketch the graph of y equals to cosec half x, we can write it as y equals to 1 upon sine of half x. And now we can assume values of x. So the first value of x we can assume is x equals to 0. We know that when we know that sine 0 is 0. So 1 upon 0 will become an infinity. So when x is 0, y will be infinity. The next value of x we can take is pi upon 2. So x is equals to pi by 2. And we'll get y is equals to 1 upon sine of, in place of x, we'll write pi by 2. So that will become sine of pi by 2 and the pi by 2 divided by 2. So that will become sine of pi by 4. So sine of pi by 4 and then we divide 1. So we'll get 1.414. And then finally, if we take x is equals to pi over here, so sine of pi by 2 is 1. So y will be is equals to 1 as well. Now, once we have these values, we know that at 0, it's coming from infinity. And let's say this is 1. So 1.414 will be slightly above. So let's take this point over here. And at sine pi, it is at 1. So that's, excuse me, that will be the graph of y equals to cos half x, cosec half x. Now to sketch the graph of y equals to e power x minus 3, we'll do the exact same thing. We can start by assuming y is equals to e to the power of 0. So e to the power, when we take x equals to 0, so that will become 1 minus 3, which is equals to minus 2. So we will be going above this value as it has to be greater than 0. Now, assuming value of x as, let's say we can take any value, let's take 1. So shift e to the power of 1 minus 3, that is minus 0.28. So let's say minus 0.28 is over here. And then let's take one value is pi by 2. So e to the power of pi by 2 and then minus 3. So you'll get 1.818. So when it's pi by 2, that is 1.818. So roughly the graph of e power x minus 3 would look like this. And this shows that they will intersect at only one point, or they have exactly one root in the interval 0 to pi. In part B, we have to verify with calculation that alpha lies between 1 and 2. So first we'll write this equation as cosec half x minus e power x plus 3 equals to 0. We'll first substitute x equals to 1 and then x equals to 2, and we'll have to show there is a change in sign. So we can first write this as 1 upon sine of half x minus e power x plus 3, and then now substituting x equals to 1 into the equation. So 1 divided by sine of 0.5 and then minus e to the power of 1 plus 3. We are getting 2 point. So this value is 2.367, and that's a positive value, only a positive value. And now substituting x is equals to 2 in the equation, we'll get 1 divided by sine of 1 minus e to the power of 2 plus 3. We are getting the value as negative 3.200. So this change of sign basically shows that the root lies between, or the alpha lies between 1 and 2. In part C, it says show that if a sequence of values in the interval given by the iterative formula converges, then it converges to alpha. So we have to show that basically this equation can be represented with like this equation. So what we'll do is we'll write it as x is equals to ln of cosec half x plus 3. Now, applying the rules of logarithms, we know that ln of x is equals to y can be written as x is equals to e to the power of y. So similarly, in this case, we can write e to the power of x is equals to cosec half x plus 3. We can bring the 3 on the left-hand side, and this will become e power x minus 3 is equals to cosec half x. So basically, it proves that we can use this equation to find the value of x as it represents the original equation. Now, in part D, it says use this iterative formula. So we'll be using this formula, which is x power n xn plus 1 is equals to ln of cosec of half x plus 3. So it says starting with an initial value of 1.4. So the first value we'll get is when we'll take x is equals to the initial value as 1.4. Now substituting this in the calculator, so we'll write it as, and we can simplify it and write it as ln of 1 upon sine half x plus 3. So in the first step, we'll do sine of bracket 1.4 divided by 2, 1 divided by answer plus 3, and then ln of answer. So we are getting 1.515. 1.515626, and we have to give our answer to 4 decimal places, so we can write it as 1.5156. Now once we have the first value, we can find the second value by substituting this value in x over here. So we'll get now, so this value divided by 2 sine of this answer, 1 divided by the answer plus 3, and then ln of this answer, we are getting 1.494. 1.4940. Now substituting this again into the equation, we'll get sine of answer 1 divided by answer plus 3, and then ln of answer, we are getting 1.497. 1.497 779. So this will become 1.4978. Then substituting this into the equation again. So we'll get ln of answer. We are getting 1.4971 again. Now, as we are getting 1.4 and we have to give our answer to two decimal place, we are getting our answer correct to three decimal place consistently. Let's do it just one more time. So sign of this answer divided by 2, 1 divided by answer, and then plus 3. And taking ln of the answer, I am again getting 1.4972, which means now I can say that the final answer will be 1.497. And as we have to give it to two decimal place, so the final answer will be is equals to 1 point. We'll add 1 over here, so this will become 1.50. In part E, it says state the minimum number of calculated iteration needed with this initial value. So the minimum number of iterations was, so we are getting 3, 4. So I think the answer should be we will be needing 4 iterations at least to get this correct to two decimal place, as uh, till for the third and the fourth iteration, we are having the answer correct to three decimal place, which is the same. So that's why we will have to do at least 4 iterations. देखो, in question number in question number 7, it says on a single Argand diagram, just 1 second. On a single Argand diagram, sketch the loci given by the equation z minus 3 plus 2 iota is equals to 2, and w minus 3 plus 2 iota is equals to w plus 3 minus 4 iota, where z and w are complex numbers. Now, what we have to remember is that we'll first write it as z minus, and in the bracket this will become 3, and as this is plus over here, so in the bracket this will be written as 3 minus 2 iota is equals to 2. Now this represents that the distance of z from this point is equals to 2. Let's make the x and the y axis over here. This point is 3 minus 2 iota, so let's say this is 1, 2 and 3, and minus 1 minus 2. So this is the point 3 minus 2 iota, and the distance of z, as this is the modular sign, is 2. It means that z can be anywhere on a circle of radius 2 centimeter, right? So let's make a circle over here like this over here, and this has a radius of 2 centimeters. It's not exactly a circle, but let's assume this is a circle. And w minus 3 plus 2 iota, so we'll write it as w minus 3 minus 2 iota is equals to w minus, so this will be minus 3 plus 4 iota. Now this means that the distance of w from this point and this point, it is equal. अब इसका मतलब क्या हुआ? We'll have to make a perpendicular bisector. So 3 minus 2 iota is, okay, so this is 3 minus 2 iota over here. We already have this over here. And minus 3 plus 4 iota. So let's say minus 3 plus 4 iota is somewhere over here. It means that w is exactly in between. I'll just roughly make a perpendicular bisector. So let's say this was the line connecting these 2 points. One of these points is 3 plus 2 iota. Let's call this point as OA, right? ये 3 minus 2 iota का point है, तो मैंने यहाँ पे A लिख दिया. And point B, let's say this is point B. This is minus 3 plus 4 iota. This means that the distance of W from these 2 points is equal. It means W can be anywhere on this line, and that is it. ठीक है? कह रहा है hence find the least value of Z minus W. अच्छा, अब देखें आप लोग. I know that W is somewhere on this line and Z is somewhere on this circle. In part 2, it says hence find the least value of Z minus W. It means least value कब होगी? जब let's say if Z is over here and W is over here, right? अभी कैसे निकाले? देखो, हमें क्या पता है ऑलरेडी कि ये रेडियस जो है 2 है. ठीक है. इफ यू हैव द लेंथ फ्रॉम ए टिल द मिड पॉइंट, और ए टिल द मिड पॉइंट हम कैसे निकाल सकते हैं? देखो, वी हैव दिस टू कोऑर्डिनेट्स. एक कोऑर्डिनेट है 3 कॉमा माइनस 2, और एक कोऑर्डिनेट क्या है? -3 कॉमा +4. अब इस वन ऑफ द मेथड्स इज मैं इसका डिस्टेंस निकाल के हाफ कर दूं तो ये मिड पॉइंट तक आ जाएगा और टू सब्ट्रैक्ट कर दूं, राइट? सो फर्स्ट फाइंडिंग द डिस्टेंस ऑफ ए बी विल गेट x2 minus x1 whole squared. So minus 3 is minus 6 whole squared minus 4 minus minus 2. So this will again become 6 whole squared. So this distance will be 36 plus है, ये तो जीरो हो रहा है, ये कैसे हो सकता है? अच्छा ये प्लस होता है x2 minus x1 plus y2 minus y1 होल स्क्वायर ना? हाँ, देखो ये भी दिमाग से निकल गया, √72 आ गया. So the midpoint or the length of, let's say, A formed A till W, the distance A till W will be √72 divided by 2, and then I will subtract 2 from this answer to find the least distance of Z and W. So the distance of ZW will be √72 upon 2 minus 2. Now in the mark schemes, the answer can be given as like this. So they put it in third form. √36 is 6. So this will become 6 √2 upon 2 minus 2. And the answer will be given as 3 √2 minus 2. So this will be the least distance. In question 8, it says use the substitution u equals to 1 minus sine x to find the exact value of the integral, giving our answer in the form a plus b √2. Now, in the first step, whenever we have to do substitution, the first thing we'll do is we'll write u is equals to 1 minus sine x, and du by dx will become the derivative of 1 minus sine x, so that will become minus cos x. Now, in place of dx, the first thing we'll do is we'll make dx the subject over here. That will become minus du upon cos x. So we'll write sine 2x upon root of 1 minus sine of x into minus du upon cos of x. Now that is the first step we should always do when doing substitution. And we can look at the limits later on. Now we know the identity for sine 2x is 2 sine x cos x. So we can write 2 sine cos upon, and in place of 1 minus sine, we can write u. So this will become square root of u into minus du upon cos of x. So we can just write cos over here. This cos and cos will cancel. And this sine, we know that sine will be, if u is equals to 1 minus sine, then sine can be written as 1 minus u as well. So in the numerator, we'll have 2 into 1 minus u upon u to the power of half into minus du. So we can bring the minus sign over here, du. And now we'll change the limits as we have our equation in terms of u. So u is equals to 1 minus sine x. The upper value is 3 upon 2 pi. So 1 minus 3 upon 2 pi. So this value will be, so sine of 3 upon 2 pi, that will be equals to 3 pi divided by 2. That is equals to minus 1. That will become 1 minus minus 1. That is equals to positive 2. And then taking sine of pi. So we'll get u is equals to 1 minus sine of pi. So 1 minus sine of pi, that is equals to 1. So we are getting the limits as 2 and 1 over here. So we'll write 2 and 1 over here. Now we'll simply integrate the equation. But before we integrate it, we'll simplify it first. We can keep the 2 outside the bracket. And 1 upon u power half can be written as u to the power minus half. And u divided by u power half. So we can just write it as 1 upon u half, u power half minus u upon u power half. And this will be equals to 1 minus u to the power of positive half. Now we can multiply this negative sign inside and write it as u power half minus u power minus half. And we can keep 2 outside with the limits 2 and 1. Now, integrating this, we'll get u to the power of 3 upon 2 as the power increases by 1, and then we divide by 3 upon 2. So this will be written as into 2 upon 3 minus the power will increase by 1 over here. So this will become u to the power of 1 upon 2. And when we divide by 1 upon 2, so 2 will be over here. Now, once we have integrated it, we'll apply the limits over here. So first applying the upper limit, which is 2. So this will be written as 2 into 2 to the power of 3 upon 2 divided by 3 minus 2 into 2 to the power of 1 upon 2. And then applying the lower limit, we'll get, okay, so we have already multiplied by 2 over here as well. No, this 2 is already outside, so you'll have to be very careful with this. This 2 remains outside. And then subtracting the lower limit, we'll get 2 into 1 to the power of 3 upon 2 divided by 3 minus 2 into 1 to the power of 1 upon 2, and we'll close the bracket over here. Now 2 to the power of 3 upon 2, so that will become square root of, and we have to give our answer in terms of a plus b root 2. Okay, so 2 to the power of 3 upon 2, that will become square root of 8 minus 2, this will be written as 2 to the power root 2 minus, this will be 2 upon 3 minus 1. And then in the end, we'll multiply the whole thing by 2. Now simplifying this, we'll get 2 root 8 upon 3 minus 2 root 2 minus 2 upon 3 plus 1. And now multiplying this whole thing by 2, we'll get 4 root 8 upon 3 minus 2 root 2 minus 2 upon 3 plus 1. Sorry, we have made a mistake over here. So this will become 2 times 2 is 4. So this will become 4 root 2 minus 4 upon 3 plus 2. Now, let's simplify this. Minus 4 upon 3 plus 2, taking the LCM, this will become 2 times 2 is 4. So this will be minus 4 plus 6, that is 2 upon 3. And 4 root 8, we can write it as 4, and root 8 can be written as root 4 into root 2 upon 3 minus 4 root 2 minus plus 2 upon 3. So root 4 is equals to 2, and 4 times 2 will become 8 upon 3. So 8 upon 3 root 2 minus 4 root 2 plus 2 upon 3. Now simplifying this, taking the LCM, we'll get 3 times 4, which is 12. So 8 minus 12 will become minus 4 root 2 upon 3 plus 2 upon 3. Okay, and just one correction over here. This was 2 times 1, which is 2. So we made a mistake over here. This will become a plus 2, which will make this a plus 4. So minus 4 plus 12 will become 8. So this should be 8 upon 3 over here. So the final answer will be written as minus 4 root 2 upon 3 plus 8 upon 3. And as we have to give our answer in the form a plus b root 2, so the value of a will be 8 upon 3 and the value of b will be minus 4 upon 3. In question number 9, the equation of two straight lines are given. The lines L1 and L2 are perpendicular. We have to show that A is equals to 4. Now, if two lines are perpendicular, when we apply the scalar product, so when we write it down, which is A dot B into AB cos theta, perpendicular means this will be theta will be 90, cos 90 is 0. So basically we get A dot B is equals to 0, where A and B are direction vectors of each of these lines. Now the directional vector of the first line is 2, minus 1 and A, and the direction vector of the second line is 3, minus 2 and minus 2, and that will be equals to 0. Multiplying, we'll get 2 times 3 is 6, plus 2 minus 2A is equals to 0. So 8 will be is equals to 2A, and the value of A will be equals to 4. In part B, it says the lines L1 and L2 also intersect. We have to find the position vector of the points of intersection. So in the first step, we can write the equation of each of these lines. The equation of line L1 can be written as, so this, the points are 1, minus 2, and 3. So this will be 1, minus 2, and 3, plus lambda of 2 minus 1 and a. And we have a as equals to 4. The equation for line L2 is the points are minus 1, and minus 1. So we'll write minus 1, minus 1, minus 1 plus mu times 3 minus 2 and minus 2. Now, as they're intersecting, we know that this represents the x, this represents the y, and this represents the z coordinates. So first writing 1 plus 2 lambda, which is our x coordinate, and as they're intersecting, so that should be equals to minus 1 plus mu times 3, that will become 3 mu. So that will give us our first equation. And we can make a second equation by writing minus 2 plus lambda into minus 1. So that will be minus 2 minus lambda is equals to minus 1 minus 2 mu, as mu times minus 2 will be minus 2 mu. Now we have two equations. We can solve them simultaneously. In the first step, what we can do is we can just write it as 2 lambda minus 3 mu is equals to minus 1, which is minus 2, and minus lambda, we bring the 2 mu over here, that will become plus 2 mu is equals to minus 1 plus 2, which is positive 1. Multiplying this equation by 2, we will get minus 2 lambda plus 4 mu is equals to 2. So 2 mu and 2 mu will cancel out. Minus 3 mu plus 4 mu is equals to, so minus 3 mu plus 4 mu, that is equals to mu, and minus 2 plus 2, that will be equals to 0. So the value of mu will be equals to 0. And once you have the value of mu, so lambda will be is equals to, now from this equation, minus lambda plus 2 mu is equals to 1. So 2 mu is 0. So lambda would be equals to minus 1. Now to confirm that the lines are intersecting, we'll substitute this into the equation for z. So we have 3 plus 4 lambda, and that would be equals to minus 1 minus 2 mu. So the value of lambda is minus 1. So that will be equals to 3 plus 4 into minus 1 is equals to minus 1 minus 2 into 0. So we'll get minus 1 is equals to minus 1. So it means the lines are intersecting with these values of lambda and mu. So now we can write down the x, y, and z coordinates. The z coordinate we got is minus 1. For the x coordinate, that was 1 plus 2 lambda. So when you put lambda equals to minus 1, so we'll get 1 minus 2, which is also minus 1. And for the y coordinate, and we can use lambda or mu any of these points. So for the y coordinate, we had minus 2 minus lambda. So minus 2 minus minus 1, that is equals to minus 2 plus 1, which is also minus 1. So the position vector of the point of intersection will be minus 1, and minus 1. And we can write it as minus I, minus j, and minus k. In part C, it says that the position A, point A has a position vector, so that line A lies on line L1. So that's straightforward. We know that if it lies on L1, we will write it as the equation of line L1 is 1 plus 2 lambda. So that is 1 plus 2 lambda. This is minus 2 minus lambda, and 3 plus 4 lambda. So if any point lies on any line, we can just substitute that into that and put it equals to the equation. So we can write this as is equals to minus 5, 1, and minus 9. Now finding the value of lambda over here, we'll get 1 plus 2 lambda is equals to minus 5. So 2 lambda would be equals to minus 6, and lambda would be equals to minus 3. Now to show that A lies on line L1, we will show that for this value of lambda, the y and the z coordinates will be 1 and minus 9. So minus 2 minus, so this will be the value of lambda is minus 3. So minus 2 plus 3 will become a 1, and 3 plus 4 lambda. So 4 into minus 3, 3 minus 12 will be equals to 9. So as the y and z coordinates are coming out the same for this value of lambda, it is shown that A lies on line L1. In part D, it says the point B is the image of A after a reflection in the line L. So what we know is that A lies on the line L1. Line L2 and L1 are perpendicular, and B is a image of a reflection after image of A after reflection in the line L2. So what we know is, let's say if this is point A, the image will be exactly perpendicular. So if this is point A, its image will be formed exactly perpendicular to this point. So the image will be, well, this will not be correct. If it is being reflected in the line L2, then that means so L2 is a mirror line. So that means B will be exactly on the other side. So let's say B will be over here, which means that if this is the mirror line and we already have this point of intersection, which was -1, -1, and -1. So that means that the distance of A from B will be the same as the distance of B from this point. So what we can do is we have this point, which is, and this will be exactly on the opposite side. So we can just uh, take a negative sign. So let's say first, let's call this point X. So if we find AX, that will be is equals to A, the point is -5, 1, and -9. So AX will be X minus A. So AX will be equals to, this is -1, -1, and -1, minus A will be -5, 1, and -9. -5, 1, and -9. So the direction vector of AX is -1 plus 5, that is 4, -1 -1, that is -2, and -1 plus 9, that is +8. So XB will be exactly the same. So XB will be B minus X. So whatever AX is, that will be the same as XB. So XB, we know that is 4 minus 2 and 8 is equals to B. We do not know. We can write it as X, Y, and Z. And minus X is -1, -1, and -1. So finally, the coordinates of B will be is equals to 4 minus 2 and 8 plus -1, -1, and -1. That will be equals to 4 minus 1, 3, -2, -1, -3, and 8 minus 1, 7. So these will be the coordinates of B, which is a reflection of A after in the line L2. Question number 10, it says that given that 2x equals to tan y, so that dy by dx is equals to 2 upon 1 plus 4x squared. Now, if you have to show that the dy dx is 2 upon 1 plus 4x squared, first we can simply differentiate it. And we know that the derivative of 2 with respect to x, 2x will be 2. And the derivative of tan is sec square. So we'll get sec square of y, and the derivative of y is y dash, which is basically dy by dx. So y dash will be is equals to 2 upon sec square of y. Now we know the identity, and that identity is sec square of x or y. So we can write it as y is equals to 1 plus tan square of y. Now tan of y is equals to 2x. So sec square of y can be written as 1 plus 2x whole squared. So sec square of y will be 1 plus 4x square. So y dash, which is dy by dx, can now be written as 2 divided by 1 plus 4x squared, as we have to show. And part B, it says, hence find the exact value of the integral of x tan inverse of 2x with the limits given. Now, as two different terms are multiplying over here, we'll have to apply integration by parts. So we have one algebraic function and one trigonometric function over here. So we can take u is equals to x, and u dash or du will be equals to 1. dv will be equals to tan inverse of 2x. So the integral of tan inverse of 2x will be, so let's, okay, and just one thing to understand over here, if this is tan y is equals to 2x, we can also write it as y is equals to tan inverse of 2x, which means that the if we find dy by dx of this, that will be equals to 2 upon 1 plus 4x squared. So we have the derivative of tan inverse of 2x, and this is what we need over here. So we can switch this around for to apply integration by parts. Yes, we apply the late rule where we take the algebraic function as u and the trigonometric as dv. But when we apply the integration by parts in this case, this is the formula over here. U dv is equals to vu minus v du. Now, as we have an inverse function over here, so we'll take this as u. That will be taken as tan inverse of 2x, and du will be taken as 2 upon 1 plus 4x squared. And dv we can take as x in this case. So v will be is equals to x squared upon 2, which is the integral. Now, applying this in the formula, vu will become x squared upon 2 tan inverse of 2x minus v which is x square upon 2 multiplied by du, which is 2 upon 1 plus 4x squared dx. Now this 2 and 2 will cancel out over here. We'll get x square upon 2 tan inverse of 2x minus x squared upon 1 plus 4x squared dx. Now to integrate x square upon 1 plus 4x square, we'll have to apply integration by parts over here. So we can write this expression as a plus b upon 1 plus 4x squared. Now finding the values of a and b first. So a will multiply by 1 plus 4x squared plus b is equals to, in the numerator we have x squared. So now comparing, we'll get a plus 4ax squared plus b is equals to x squared. So 4a, which is the coefficient of x squared, is equals to 1. So a is equals to 1 by 4. And a plus b, which is a constant term, will be equals to 0 as there is no term over here. So 1 upon 4 plus b equals to 0. B will be equals to minus 1 upon 4. So now we have the values of a and b as well. We'll write it as 1 upon 4 plus or minus in this case, as b is minus, we can write it as minus 1 upon 4 into 1 plus 4x squared. Now to integrate this, what we can do is we can just write 1 upon 4 as common outside, and we'll get 1 minus 1 upon 1 plus 4x squared dx. Now to integrate 1 upon 1 plus 4x squared, we'll apply this integration where if we have a function of the form 1 plus x square plus a square, that can be written as 1 upon a tan inverse of x upon a, and this is given in our formula sheet as well. So we have 4x square plus 1 in this case, so we'll write it as 2x whole squared, or we'll take 4 common as we need the coefficient of x square as 1. So we'll take 4 common over here, we'll get x square plus 1 upon 4, which will which can be written as 1 upon 2 whole squared now. So this will become 1 upon 2 whole squared. Basically, this requires a lot of practice prior to doing past papers of integration, so that we remember how to integrate these individual terms. So the value of a over here becomes 1 upon 2. So 1 upon 1 upon 2 becomes 2 is equals to 2 tan inverse of x upon 1 upon 2, that will become 2x. And this 4 remains in the denominator over here. So 2 upon 4, that becomes 1 upon 2. So we'll get 1 upon 4 into 1 upon 2 tan inverse of 2x as an integral. And then now we can bring our previous terms over here. So the previous term was x square upon 2 tan inverse of 2x. So that was x square upon 2 tan inverse of 2x minus this. And then finally, now we can substitute the limits. The upper limit is root 3 by 2. So we'll write root 3 by 2 whole squared upon 2 tan inverse of 2 into root 3 by 2 minus 1 upon 8, we can write it as, tan inverse of 2 into root 3 by 2, and then we'll subtract it from the lower limit, and the lower limit was given as 1 upon 2. So where is it? Okay, so that will become, we'll subtract it, so the lower limit will be 1 upon 2, so that is 1 upon 2 whole squared upon 2, tan inverse of 2 into 1 upon 2 minus 1 upon 8 into tan inverse of 2 into 1 upon 2. Now we'll simply substitute all of this in the calculator and find the final answer. And just one small correction over here. I just checked that I did not take the integral of 1 over here. So that would have become 1 upon 4 as well. And one very basic mistake, that this was a negative sign over here. So once we have integrated this side, that became basically, so we had 1 upon 4, the integral of 1, that becomes x. So this will become 1 upon 4x minus, we got 1 upon 8 tan inverse of 2x. So this was the integral, and there was a negative sign outside, and then we had x square of x square upon 2 tan inverse of 2x. So this will become minus, and this should become a plus over here. So we just have to do a quick correction over here. We'll get x square upon 2 tan inverse of 2x minus 1 upon 4 plus 1 upon 8 tan inverse of 2x. And now we'll apply the upper and the lower limits and substitute this in the calculator. So we'll have a plus over here. This will become plus and minus 1 upon 4x. So minus 1 upon 4 into root 3 by 2. And over here as well, this will be a positive sign. And this will be minus 1 upon 4, and the value of x is 1 upon 2. Now substituting these in the calculator. So root 3 square is 3 upon 4. So that will become 3 upon 8. 2 and 2 will cancel out. Tan inverse of root 3. So if we substitute this in the calculator in radian mode, so tan inverse of root 3, that will be equals to pi upon 3. So this will become pi upon 3 plus 2 and 2 will cancel out. Tan inverse of 1 is pi upon 4. So that will become pi upon 32. Okay, sorry. So I mixed it up again. This will be tan inverse of root 3 again. So tan inverse of root 3 is pi upon 3. So that will become pi upon 24 minus root 3 upon 8. Subtracting it from the lower limit. So this is 1 upon 4. That will become 1 upon 8 into tan inverse of 1, which is pi upon 4, plus again tan inverse of 1 is pi upon 4. So that will become pi upon 32 minus 1 upon 8. So 1 upon, okay, now simplifying this, we'll get 3 pi by 24 plus pi by 24 minus root 3 by 8 minus pi plus pi is 2 pi. So that is 2 pi upon 32. So we'll get, yeah, so this will be minus 2 pi by 32 and minus minus plus 1 upon 8. Now simplifying this, 3 pi plus pi is 4 pi. So we'll get 4 pi upon 24 minus 2 pi by 32, and then minus root 3 upon 8 plus 1 upon 8. So we can just simply write it as minus root 3 plus 1 upon 8. And then simplifying this in the calculator, we can get a final answer, which will be equal to, so this will be 2 upon 12, and this will be 1 upon 16. The LCM of 12 and 16, that will be equals to 48. This will multiply by 4, so that will become 8 pi, minus this will multiply by 3, so that will become 6 pi, and this will remain 1 upon, this is 1 upon 8 minus root 3 upon 8. So that will become 2 pi upon 48, which is 2 pi upon, we can write it as pi upon 24 as well. So that will be our final answer.